Hello, my name is Stacy Wright, and I would like to welcome you to the Designing for Wildfires training series presented by the Federal Emergency Management Agency's Building Science Disaster Support Program. This is Module 5 of a 5-part series by the Marshall Fire Mitigation Assessment Team, or MAT, and focuses on defensible space. In this training series, the MAT hopes to expand knowledge of wildfire vulnerabilities in the built environment at different scales, from the community and neighborhood level to the subdivision and individual lot scales, and discuss resources and best practices. This training is Module 5, the final module in a series of 5 modules. Darlene Reaney and Amelia Pluto will guide you through this final module.
So before we get started, we thought it would be a good idea to cover some basic concepts regarding key heat transfer mechanisms that allow wildfire to spread into the built environment and potentially lead to ignition of a home or structure. So understanding these fundamental mechanisms should help clarify and/or justify the need for defensible space measures, in addition to structural hardening measures discussed in Module 4. But also, this should give you some basic fire science knowledge that can be applied to any condition on a property. And so the main goals then boil down to 1, limiting the ability of a fire to spread uninterrupted from adjacent wildlands and/or open spaces directly to the home or structure, whether via direct flame, hot gases, or radiation. And then 2, limit the likelihood of embers igniting receptive fuel beds and other combustible items within a property that then leads to structure ignition. So the 3 main heat transfer mechanisms for how fire can spread and potentially ignite a structure are shown here. These mechanisms are relevant for fires that spread from wildlands to structures, as well as from structure to structure within the built environment. So one heat transfer mechanism that can lead to structure ignition from a wildfire is direct contact by the flaming region of a fire or hot gases from the plume of a fire. So this diagram here is showing direct flaming from vegetative fuels, but this same mechanism can occur from a fire originating from another building. So this form of heat transfer is the most critical, as it almost guarantees ignition of a structure due to the intensity of heat that the flaming region of the fire imposes on the structure. And this can occur when either wildland fuels are allowed to continue uninterrupted to and in close proximity to a structure, or when landscaping around a structure is poorly maintained and is within close proximity to the building. For example, within 5 to 10 feet of a structure. So columns of flame and intense gases can ignite the building and anything flammable they contact. So this particular heat transfer mechanism is also of concern, particularly in high wind events, because flame and hot gases, even when the fuels are, say, 10 to 30 feet away, can still come into contact with a building, as the high winds can push the flames and hot gases laterally to the structure. So the second heat transfer mechanism that can lead to structure ignition from a wildfire is radiation. And so radiation is the process by which wildfires, or fires in general, heat up the surrounding atmospheric environment that could potentially lead to ignition of a building, even without the flames or hot gases coming into contact with the structure. So radiation can also break glass in windows or doors, thus providing an avenue for flaming debris and/or embers to enter the building. Radiation can be a concern even as far as 100 or 200 feet away, depending on the intensity of fire and the wind conditions. So the final heat transfer mechanism is via embers. Embers, are also known as firebrands, are burning materials from wildfires or structure fires. Embers can be anywhere from 1 to 3 centimeters in size, or as large as flaming sections of building materials, leaves, root balls, and other forms of flaming vegetation or urban fuels. Embers are a major concern in wildfires, as research has indicated that nearly 2/3 of all structure ignitions can be attributed to embers. Embers, again, are particularly of concern during high wind fire events, as they can travel anywhere from 1 or several miles ahead of the fire front. So given this basic understanding of the main heat transfer mechanisms in a fire, we will now focus on the practical ways in which various defensible space measures can help slow or stop these mechanisms from leading to structure ignition. So as we learned in Module 3, there are a variety of building construction features that can be designed to help limit ignition as well. For this module, we'll be going over aspects of defensible space that can also help limit the likelihood of structure ignition. So defensible space is defined as the area around a home or structure where the location, selection, and maintenance of vegetation and other combustible materials are managed such that a fire or wind-blown embers are less likely to ignite the structure. So this managed area provides essentially a defense against the fire to reduce the structure's exposure to radiation, direct flame contact, and ignition from embers. And again, these are considered the three main principal factors of ignition in a wildfire. So while there are several key issues or concerns regarding how we design and plan for defensible space measures, one key concept that we should be aiming for is survivability of the structure, as opposed to designing a building to be defensible. Since defensible implies that someone or something will be there to help protect the structure actively from potential ignition. So during most major wildfires, first responders will likely be unable to actively defend every individual home or neighborhood. And during the Marshall Fire and other similar large-scale fires that we've seen, most buildings and homes were not defended due to either unsafe conditions the fire presented or because resources were stretched thin. So this is critical information of the reality of how most wildfire incidences are responded to, and so how one should approach defensible space around a property. It becomes essential for property owners to take proactive measures so their homes and yards survive with or without defensive action by first responders. That said, properly developed and maintained defensible space will also create a place of relative safety that may increase the likelihood of first responders to defend a property. So firefighting availability and capacities to defend all structures is just one key issue of many. The next set of slides will touch on some additional issues and challenges in the built and natural environments that can impact defensible space considerations. So one key challenge that was observed in the Marshall Fire, but in many other recent wildfires, is the presence of large unmanaged wildland or open space that directly abuts suburban or urban landscapes. So fire in these spaces, whether intermixed or next to a community or home, can present a significant risk to structure ignition. For one, as these spaces provide continuous fuel loads and can be remote from detection, fire department access, and suppression capabilities, a fire in these landscapes can quickly grow to uncontrollable levels, making it challenging and sometimes impossible to contain once fire service personnel arrive. Thus, the interface of these large landscapes with the built environment, if not managed or considered in city or community land use planning, can easily ignite homes and community assets. Another key challenge for maintaining appropriate defensible space is the large range of landscaping and uses that property owners and communities have in and around buildings and developments. There's a wide range of vegetative types, whether trees, shrubs, flowers, or grasses, various plant characteristics and arrangements, so height, growth type, native versus non-native, etc. Land purposes, so whether the vegetation is used for food, shade, or recreation, various fire ecology attributes, and obviously quality of ongoing maintenance. So these man-made landscape environments can be just as combustible as wildland vegetation and can provide a pathway for fire to spread from wildlands, open spaces, and greenbelts to homes or structures, both horizontally through surface fuels or vertically as ladder fuels from grasses and other low-lying vegetation and accumulated debris. So another key issue with understanding and designing appropriate defensible space measure is the limited amount of guidance, codes, and standards on knowing what plants and trees can be considered as either fire safe or quote unquote approved, and those that are considered hazardous or prohibited. While some areas have compiled lists of both approved and prohibited plants to help guide owners in landscaping design, most places do not have these resources. And so the ability or inability to resist ignition for plants and trees is dependent on numerous physical characteristics of the plant. Many of the existing lists, while potentially beneficial to homeowners, can be incomplete or misleading and can provide a false sense of security. So these lists, of course, are highly dependent on a variety of local factors that may not be relevant to other locations. And the numerous factors that can influence whether or not a plant is considered hazardous or not hazardous is quite variable. This can range from, the type of species, the structure of the plant, what type of products such as resins the plant produces, branching patterns. So a huge array of different characteristics about the plant or tree that will dictate whether or not it's considered hazardous. In addition to that, there's other factors such as how well the plants or trees are maintained, as any plant, if not well maintained, can become a hazard. So another key issue with defensible space is site constraints, and we'll be touching on this again in later slides. Most existing codes, standards, and guidance on defensible space assume a property owner has 100 feet of side yard around their building. In many regions, and as we get into more suburban and urban land uses, 100 feet of defensible space is typically not available. In these contexts, property owners have less guidance on how best to augment their property to account for hazards that are not within their control, whether due to limited setbacks to property lines, adjacency to unmanaged vegetation from other property owners, vacant lots, and just distances to other buildings on adjacent properties. So another key issue that was mentioned earlier on in the module is the uncertainty and unpredictable nature of embers and how they can present various ignition risks to a property. So as previously mentioned, about 2/3 of most structure ignitions have been attributed to embers. And so given the fact that embers can travel as far as a half a mile to several miles ahead of the fire front, fire-prone WUI areas may be larger than we currently understand. So the last key issue with defensible space is the fact that in addition to a large variability in vegetative landscaping around a structure, there's equally a large range of other combustible fuels that may be stored around a property and adjacent properties that can threaten a structure. So this includes things such as outbuildings or pergolas, sheds, pool supplies, storing of firewood or trash and recycling receptacles, outdoor furnishing, and other types of decorative landscaping. So these fuels can present additional challenges in being able to predict fire behavior and damage loss potential in the WUI.
So we're gonna switch now to talking about some best practices and guidance on implementing defensible space at the parcel and building level during design and construction. There are many different design components to consider from the top of the structure down and out into the defensible space zone. So we'll touch on a few of those. Defensible space is the area of the home ignition zone that extends from the structure's foundation and exterior wall out 100 or more feet. There's a lot of literature and guidance available on defensible space, so we won't be going into great detail. And we also want to highlight there are many different naming conventions out there that you'll see, but the underlying principles are the same across all of them, which is that the highest risk area for structure ignition in a home in the structure's yard or landscaping is within kind of that first 5 feet next to the structure. So in the naming convention we're using today, that gets called zone 0, that 0 to 5 feet immediate zone. This area is recommended and in many jurisdictions required to be non-combustible. So no combustibles of any kind, including live vegetation, mulches, or ornamental grasses. As we move farther away from the building, the requirements for maintaining landscaping and types of plants and configurations relax somewhat. And so we'll talk about zone 1, which is 5 to 30 feet, the intermediate zone, and then zone 2, which is 30 to 100 feet or more, the extended zone. There is additional detail about specific guidance and requirements at this link, but again, and I'll be saying this a few more times, there is certainly local, more detailed guidance, so referencing your local standards is prudent. So in zone 0, the 0 to 5 foot non-combustible zone, it's recommended and or required to use hardscape like gravel, pavers, concrete, and other non-combustible mulch materials. Another recommendation is to design a 6-inch vertical non-combustible zone at the bottom of exterior walls of buildings, and to not have any storage shed or other ancillary structures in zone 0, to have those further away from any structures in zone 2. And then anything attached to a building like fencing or gates or arbors, that first 5 feet should be non-combustible. So at the bottom here, there are a couple examples of buildings with that 5 foot of non-combustible gravel around the structure. Moving a little bit further away from the building, so now we're in zone 1, the 5 to 30 foot intermediate zone, or lean, clean, and green zone under this naming convention. The goal here is to limit connectivity of garden beds, shrubs, and trees. And the recommendation is to design areas of irrigated and mowed grass or hardscape between more lush vegetated islands. A key goal here is also to reduce ladder fuels, which Darlene touched on earlier, which connect surface fuels like those grasses to tree canopies. So this can include things like removal of lower branches. It's recommended to select plants that have minimal grow-in, lean-in, or fall-in potential over the plant's lifetime, and to have no hazardous plants within at least 10 feet of the home. And again, we recommend that you refer to local approved or recommended plant lists, and also to hazardous and prohibited plant lists that your local jurisdiction may have, since that'll have a lot more location-specific detailed information. We also want to warn that there are sometimes statewide or regional lists that can be helpful, but can cover a lot of different local ecosystems and conditions, so they might not be appropriate for every local level condition. So here's some examples of landscaping in zone 1. You see those islands of vegetation separated by hardscape, and also an example of a recommended landscaping. This is from Idaho Firewise, that gives some information about more recommended plants and plants you want to avoid that may be sort of similar aesthetically. And moving out finally to zone 2. So this is 30 to 100 feet, or in some jurisdictions, more than 100 feet from the structure. And the recommendation here is to integrate fuel breaks to interrupt any continuous vegetative fuel paths that may exist between open space or wildland fuels or green belts and the structure. So vegetation here should be in individual, well-spaced clumps or islands of trees or shrubs, surrounded by areas of non-combustible materials. It's recommended to use hardscape features like driveways or paved or gravel walkways or non-combustible patios to create fire breaks throughout the yard in this zone. And in terms of specific vegetation, fire-resistant low-volume vegetation is recommended that retains moisture and needs less maintenance. And so now we're going to talk about some more specifics. And so beginning with guidelines for spacing of vegetation. We've been talking about how that spacing is important. Most of the guidance available is based on flat terrain. And as you get into more slope conditions, there are some general rules of thumb that can apply, which is largely that the steeper the slope, the more those vegetation should be spaced out. So as you can see in this image, right, as we go from mild slopes, it's okay for some of those shrubs and groupings of shrubs and trees to be closer together. And then as we get into those steep slopes of greater than 40%, grouping of shrubs is not allowed, and trees should be further apart. And again, this is a situation where the local fire department, state forestry agency, registered professional forester, or fire ecology or safety professionals can be consulted for both location-specific information and site-specific information. We also talked about planting and utilizing fire-resistant plants. And so there are some general rules that exist and rule of thumbs about plants that are typically more to less fire resistant. And again, we point you towards local approved plant lists, but there's also, it's important to keep in mind, many factors that will affect plant flammability. So this includes species and genus and plant structure, but also includes things that may vary, between the same species. So things like topographic location, surface mass, size and density of foliage, and crucially, maintenance practices, as well as local weather and weather history can all impact the fire resistance of plants. So where available, we recommend that approved plant lists or recommended plant lists provided by the local jurisdiction are utilized. And these will typically include specific information about plants that are recommended because they are drought resistant, contain more moisture, have low amounts of volatile oils and other readily flammable chemicals, are typically non-invasive, slow growing, produce less litter and dead material, are low growing, and are sustainable without supplemental fertilization. These may vary based on the criteria a jurisdiction is using in their improved plant list, but this is typically some of the criteria that feed into that. On the flip side, we also recommend utilizing prohibited or hazardous plant lists, and some of the criteria that goes into determining if a plant is prohibited or hazardous are low moisture content, having volatile resins and oils, and one way to check for this is that they're generally aromatic when crushed, narrow leaves or long thin needles, or waxy or fuzzy leaves. Plants that accumulate dead leaves and twigs on or under the plant, loose or papery bark, and invasive species. So some examples of typically hazardous plants are shown here. And again, which plants are hazardous is going to vary place to place, but there are some plants that are commonly hazardous and also very commonly seen. These are things like juniper bushes, palm trees, Italian cypress, acacia, cedars, eucalyptus, fountain grass, and scrub oak. And we have some images of some of those most typical plants up that you might recognize in your communities. But just the species of plant isn't enough to say it's hazardous or recommended. The environmental settings really matter. So part of this is the topographic location. So slope and aspect that a plant is on will make a difference. Weather and weather history vary across regions, so that will play into how a plant grows. And then just underlining that what's considered recommended in one location may be hazardous in another. So all that location-specific information is very important. And so moving on to talk about landscaping and the arrangement of these plants that are being selected from these approved or recommended list. Clustering of trees and shrubs, so continuous clustering over a large area, provides an uninterrupted fire flow path to the home. So it's important to reduce the connectivity or continuity of vegetation and create islands of vegetation or mosaic patterns, and increasing that spacing between trees and shrubs. But it's also important to highlight that fire-resistant landscapes can be aesthetic. It's not just a moonscape and hardscaping. So we have some examples here of landscaping that is reducing that connectivity, fire resistant, but still very appealing. And very, very importantly, is maintenance of the landscape, right? Any plant can burn, and even a plant on a recommended or approved list can still burn. Plants grow and shed. This can look differently as a function of species, topography, weather, and climate conditions. But to some degree, all plants are growing and shedding. And so it's important to build maintenance into the plan, and also to put the right plants in the right places. So just as an example, electrical utilities will have different rules for their infrastructure and geographic location, based on what part of the location the planting is happening in. And the similar concept applies to plant selection near homes. And so one last time, we'll encourage you to consult with local resources to get that region-specific and site-specific information. And so just as an example, here are sample tree requirements for an electrical utility, showing that in different places, different types of trees are allowed.
Okay, so far we've been touching on various recommendations and guidance on how best to maintain defensible space in general, and particularly with the assumption that we have sufficient yard space to meet the full fuel modification zone requirements. However, what happens if you don't have enough space? So in these contexts, applying the concept of communal defensible space is a practical way in which a group of structures can achieve defensible space collectively. And so what this means is that landscaping and other defensible space measures, particularly for zones 0, 1, and 2, are shared across property lines, and that the design of the vegetation and landscaping should be coordinated to help protect structures across all parcels. In addition to applying communal defensible space concepts, property owners that are in close proximity to other adjacent neighbors should also think about increasing structural hardening measures on the face of their property that directly abuts adjacent neighbors. And so these additional measures can further help increase wildfire resiliency of buildings and properties with various site constraints. So this slide here is basically providing a number of different provisions that can be employed by a group of property owners where they are sort of sharing communal defensible space or are in close proximity to another property or another building. And so this can include things like installing vent covers and other flame resistant vent products on the face of the building that closely fronts another property or building, increasing the construction of the exterior facade or wall assembly to be 1 hour fire resistant, using non-combustible siding with non-combustible or ignition-resistant materials and insulation, using non-combustible decking, fencing, and other types of non-structural attachments, eliminating the use of combustible non-vegetative features such as ornamental grass, sheds, pergolas, and other types of man-made fuels that might be on sort of this shared close proximity yard space, as well as limiting glazed openings, and if not feasible, providing double pane windows, tempered laminate glazing, or other types of non-combustible shutters. So as we wrap up Module 5, we did want to leave you with a few main points. Hopefully throughout this 5-part series, we've imparted upon you the importance of thinking about wildfire resiliency at different scales. And so in the context of defensible space, we really need to be thinking about how community and neighborhood factors and hazards, configurations, types of vegetation, layout of that vegetation, and other types of features in the natural and built environment at these larger scales can impose hazards and risks at the parcel and building scale. And so being sort of aware of these different types of scale factors, then to think about how can we best augment or design what we do have control over with respect to defensible space around our own individual building or parcel. The next point that I wanted to make is that throughout this module, Amelia touched on a number of ways in which we can increase defensible space resiliency with respect to plant selection, thinking about spacing of plants, landscaping design, and other types of features that we can influence around, the details of defensible space, as well as non-vegetative fuel loads and how those are spaced around, structures that are important and worth protecting. But maybe the best takeaway from this module is that a lot of those features or best practices still rely heavily on maintenance. And so if we as designers, authorities, or owners can build in some inherent fire resistance with the types of materials, whether they're vegetative or non-vegetative, can be more resilient on their own without maintenance, then that would be a more resilient and sustainable design over time. The next point we wanted to make is that oftentimes we don't necessarily have sufficient space due to site constraints or other variables that really limits our ability to control the defensible space zones within our own property. And so within those contexts, relying on neighbors or working with neighbors to develop communal defensible space so that the collective sort of defensible space for all the close structures or close parcels can benefit from each other's defensible space measures as a whole, then that would help obviously improve the likelihood of reducing ignition for individual structures, but all the structures as a whole. But on top of that, to provide more robustness and resiliency is to think about including additional structural hardening measures for each of the individual structures along the aspects that are fronting on other buildings or properties that are in close proximity. And then finally, just the last takeaway is that, again, Amelia touched on many factors that can affect plant flammability or tree flammability, as well as the inherent fire resistance of these of different types of plants and trees. And so, as always, as repeated again, really consulting with local fire departments, local experts on fire ecology, or other fire safety professionals can really help you as an owner designer ensure that what you're proposing in terms of plants or trees really work and provide that fire adaptive landscape that works for your specific property in your specific geography. And that, again, a reminder that regardless of what you plant, all
plants, can burn, all trees can burn if they're not well maintained, and that all plants and trees, they do grow, they can get closer to a property, and they also can shed and provide, dead debris or other type of debris that can be ignitable by embers. And so again, just reinforcing that maintenance and upkeep is a real critical part of ensuring that the space around your home is resilient to fires. And so just as a reminder, there are several products, MAP products that came out of the Marshall Fire. There's the main report as well as 7 additional fact sheet documents. Those can be found here through this link as well through this QR code. You can also do a general search on Google or other kind of search engine and look up FEMA Marshall Fire MAP products. So with that, we hope you enjoyed this 5-part series, that you found the information helpful and useful in your future projects. Thank you.
That wraps up the final module of the Designing for Wildfires training series presented by the Marshall Fire MAP. We hope this training series has been informative. On behalf of FEMA's Building Science Disaster Support Program, thank you for taking the time to review this module.